All right, we're going to be doing the division properties of exponents. All right, so in other words, let's say we have 2 to the 7th over 2 to the 4th. Well, 2 to the 7th, which is 2 times 2 times 2, 7 times, gives you 128. 2 to the 4th power gives you 16. And 128 divided by 16 is 8, which is the same thing as saying 2q. Well, this is the long way. All right. The quotient property of exponent states that if I have a base to an exponent divided by the exact same base to another exponent, all you have to do is subtract the exponents. So in other words, 7 minus 4. Remember, take the top minus the bottom, and 7 minus 4 is equal to 3, which is that right there. All right. So when you're doing these problems, when you divide numbers with the same base, subtract the exponents. All right. So here the bases are the same. So you keep the base, but subtract the exponents. 9, the top exponent minus the bottom exponent. So 9 minus 6 is 3. So x cubed will be your answer. All right. And for this one, you have to keep the base, take the top exponent minus the bottom. And therefore, you get x is equal, or x to the 6th power. All right. So let's look at another example. So we've got 2 to the 4th, which is 16, 2 to the 7, which is 128. In other words, we took the previous problem and we just flipped it. You get 1 over 8, which is equal to 1 over 2 cubed. So the bases are the same, so you keep the base, you subtract the top exponent minus the bottom. All right, so you get 2 to the negative 3rd, which is this right here. All right, but you can't have negative exponents. So therefore, you have to rewrite it as as equal to 1 over 2 cubed. In other words, the negative tells me you move it to the bottom. See, this is understood to be 2 to the negative 3rd over 1, which is this. Negative exponent means you take all of this and you move it to the bottom. Or if it's already in the bottom, you move it to the top. So at the top, you move it to the bottom, and therefore we get this. All right. So that leaves us to negative exponents. So you have a negative exponent. In other words, a negative exponent, wherever the base is, if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. All right. So let's look at these examples. So this becomes 1 over 2 cubed. 32 becomes 1 over 5 squared. 34 is 1 over 3 squared. 4 to the negative 3rd is 1 over 4 cubed. This one, now look here. These two, right? That negative 6 goes with the base x, not the 3. So this base has a negative exponent. So that means the 3 stays, and the x to the, you have 3 over x to the 6. And same thing for this one. The 5 stays because negative 4 just goes with the x because there's no parentheses, so therefore negative 4 power goes to x. So that's 5 stays, but therefore x to the negative 4, so it'll be x to the 4 goes on the bottom. Now if I want the whole thing, see, if I had 5x parentheses to negative 4, then that means I would get 1 over 5x to the 4th. All right, so if there's no parentheses, then these coefficients have to stay. All right, so now it leads us to the quotient, or power of a quotient. It's just very similar to the one we did with multiplication. If inside the parentheses, all right, I have a fraction, and on the outside is raised to power, that means I can take each of these bases to the exact same power. So what that means, like for 37, everything's in parentheses, therefore it'll be x to the third over 2 to the third. 38 will be 5 squared over y squared. 39 be 2 to the fourth over 3 to the fourth. Okay, what I want you to do now is pause, do 40, 41, and 42, and when you're done, hit play and then check your answers. So 40, you should get x squared over x to the fifth. 41, you get 2 cubed over a cubed. And 42, 3 cubed, 4 cubed. All right.